Oh, hi, everyone. Oh, hi, Rathbo. Yeah. Hi, Mr. Agar. So today we are looking at the ambiguous cases of some ambiguous sine law triangles. Let's take a look. So here are some examples of like the types of triangles we just looked at, where there's multiple triangles possible based on the information given. And they'll often look like this, one of them an obtuse triangle and one of them an acute triangle. All right. And the way that I think about this is, and like how many different triangles we can make, is I encourage you to imagine the following situation. Okay. And you might want to sketch this onto your notes. Imagine that you have a crane that's part of a traveling circus. Okay. So here is the crane that travels around on its wheels. All right. And then there's an arm of the crane like that, that can lift things up at some angle theta, and it has some length b, and then there's a trapeze artist that hangs from that hangs here from the crane and swings like this. Okay, and notice that he or she or they would be swinging through some semicircular type of orbit around the end of that crane. All right. Now, if you are the driver of that crane, you could lower the this thing so that it's just high enough down here where your what is that? It's a horse, obviously. There's the horse. Okay, where the trapeze artist can smoothly get onto the horse at one point. Okay, that would be a case like this, where the trapeze artist swings down and just hits the bottom there. Just clips it perfectly. Okay? Just kisses the bottom. That's going to be at a right angle, right? They are going to be hanging at the bottom of their swing, and it creates a right angle. Okay? Mathematically, if you apply the sine law, so this would be a situation here where, like, if b sine a over a equals 1, then a is a right angle. There. Boom. Okay, that produces a right angle triangle. Not sine A, but it's a right angle triangle right there. Okay, if that's 1. Yeah, if this is 1 here. Why is that 1? Well, this came from sine A over A is equal to sine B over B. And if I multiply both sides by B, chung chung, and this B comes up here, then B sine A over A, if that equals 1, then sine of B is 1. And we remember in the unit circle, sine is 1 up here at 90 degrees. Chung, 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 chung. Right? Right. Yeah. So that's where sine is 1, up there at 90 degrees. So that would create this right angle here. Okay? Cool, right? Yeah. Yeah. So that's what creates a right angle triangle in those situations, in these exact situations here. Okay? Now, carrying on, there are, if you look at it this way, and now you imagine that B is the arm of that crane, and A is the trapeze that the trapeze artist is hanging from, it's bad news for the trapeze artist, right? Yeah. Because the trapeze artist, if they drop from the crane side, are going to hit the ground on that side, or if they drop from away from the crane, they're going to hit over here. They're either hit the ground there or there. And they have the choice of 2 places, and they're both bad. Yeah. At what velocity? Well, it depends. So it's like they get spun on the crane and then the crane lowers down suddenly. That might be pretty bad. Yeah. Anyhow, these situations can produce 1 or 2 triangles. In the case of the UFO that we looked at today, that was 2 different triangles are possible given the information I gave you. Okay. And these produce when B sine A over A is less than 1, and B is greater than A, that means the arm of the crane is longer than the thing the trapeze artist is swinging from. That's the situation where you can create 2 triangles. That's particularly what we're going to be looking at today. And then there's one other situation, that is, there are no triangles. That's when the trapeze artist happily swings back and forth and never even touches the ground, way above the ground. That's not a triangle yet. That's like 3 lines that don't touch at one corner. It's not a triangle yet. So that's when b sine a over a is greater than 1. We would say there's no solution. And your calculator will tell you there's no solution as well. If you have, because this is like sine b over here. If sine b has to be bigger than 1, sine b can't be that because the maximum value for sine is 1. If you're asking it to be bigger than that, sorry, you can't make a triangle. We can't make a triangle that does that. So let's take a look at some examples. I don't want to look at these ones. I want to look at this one. Okay. So given triangle ABC with big B is 34 degrees, little b is 15, and C is 20. Okay. Let's find two possible measures of angle C. Okay. So this one is giving us there are multiple triangles possible. So let's draw our first triangle. Here is side B. Okay. Here is side C. So that's C equals 20, B equals 15, and then we have another angle in there, 34 degrees. Okay, so that's one triangle. And we want to find angle C over here, opposite that little side C. So let's go ahead and find that angle C. Okay, I'm just going to zoom in. Not because my diagram is beautiful, but because it gives me more space. All right, let's use sine law. Sine law is what's available to us here. It is an ambiguous case, and I'll show you how to navigate the ambiguous case using what we know about the cast rule and angles in standard position.
Ambiguous, I missed
Multiple answers possible. It would be like saying, where does the equation y equals x squared minus 1 cross the x-axis? Crosses at two places, minus 1 and 1. So it's kind of, we don't call that ambiguous, but there's similar levels of ambiguity.
What are we trying to find, sorry?
Angle C. So let's do this one here. We would say sine 34 over 15, yeah, is equal to sine C over 20.
Sine 34 over 15 times 20.
Yeah, so let's multiply here, both sides by 20. All right. And then we get 20 over 15, which reduces to 4 over 3. So 4 over 3 is 15 over 20. Sine 34 equals sine C. Let's punch it. And I can punch my unreduced fraction. I could punch 20 over 15 without too much trouble. 20 times 34, but I take the sine of it, divided by 15 equals, well, that's sine C, 0.746. 0.746 equals sine C.
Is it 3 decimal points, or can you choose 0.75?
Yeah, I'm not even going to round. I'm going to use the value that's still on my calculator. So now I take sine inverse. I'm just writing that so I have something to write down. Sine inverse 0.746 equals C. Let's find out C. Over here, see, I still have the whole decimal there, Ben?
Yeah.
And I just do trigonometry second function inverse sine to tell me 48.2. Okay? 48 is plenty of detail. I'm going to be fine with 48 degrees equals C. Okay, circle it. That is one of the possible answers.
48.
48. Now, if I told you that I had an angle that had the same sine as 48 degrees, what other angle would be a solution to this equation?
We were doing practice this last week.
Yeah. There is one other angle that also has a sine of 0.746, and it's positive.
It's
Yeah, I'm going to draw another diagram here.
It's on the other side, is it not?
Yeah. Here is the side length 20. That's C equals 20. Here is B equals 15. And then here is this other side here. This is still a 34-degree angle. Notice all I did was I kind of flipped B to the other side. It's like the trapeze artist hitting the ground from close to the crane instead of far away from the crane. It's two spots. See that?
Is it 133?
This angle here, C, will be bigger. It's obtuse. It's bigger than 90 degrees.
Is it 133?
130.
Oh, no, that can't work.
Yeah. So the way we would find that.
This doesn't work on here because you can't have it over 100.
Sine inverse of 133. No, that's not the sine inverse. 133. No. Sine inverse.
Oh,
so
no, it's 133. It's 133.
Yeah, like 132. Yeah.
132, 133.
Yeah, 132. Yeah. So here, what we would do if we want to find that angle, if I know, let's take a look at my XY plane here. If I'm looking for an angle, there's my 48 degrees. Okay? And I want the other angle that's the same. I know cosine's positive over here. All of them are positive over there. That's why I'm getting a positive value for sine. And then sine is positive over here. For angles between 90 and 180 degrees, sine will also be positive. So there's another angle over here that's a reflection through the xy axis. This would be 48 degrees here, and I would be subtracting that from 180 to find this angle. Okay, all right. So that angle, let's call it theta. Okay, theta will equal 180 minus 48 degrees. And that will be 132 degrees. Now, watch this. Here is the angle that we had. And if I take the sine of that, that was the sine that we had here, 0.746, right? 0.745, blah, blah, blah. Clear that. If I take a 132 and take the sine of it, oh, that looks awfully familiar, 0.743. It's the same, it's just different by rounding. It's just rounded a little bit differently, but it's the same value. Okay. So there were two possible answers for sine that answered that question, and we need to know which one is the correct one. So this one is correct for this one here. This is 132 degrees. So then we would finish this question. We want to remember, what were we asked for? Determine two possible measures of angle C. So therefore, angle C equals 42 degrees. Oh, sorry, 48 degrees we had. 48 degrees here, or 132 degrees. Okay, there we go. So we have to figure out two different values for angle C. And they come from two different diagrams. One looks like that, one looks like that. You can think of it, one is we're looking at the UFO the same direction. The other one, the UFO is between us and much more dangerous. Let's keep going. All right, solve the possible triangles DEF, given by DE, and D is 32 degrees. Okay, so solving the triangles means tell me all the side lengths and all the angles. That's a solved triangle, meaning you've told me all the possible information. Let's go. So let's draw it. All right, and let's draw it in black for fun, one of the triangles. Here is side D, and we'll draw it leaning out that way, 5. Here is side 8. We'll draw it leaning out that way. That's 8. And then this side in between here would be 32 degrees. Let's label that big angle D. That almost looks like a B, but it's the big angle D. This side is E, so this is angle E over here. And then we'll call this C. C, and this is side C down here. All right, let's go. Okay, yeah, I agree. There's one other triangle that's possible. And we'll do it in forest green. And it would look like this. The side 5 is leaning the same way as the side 8. Like that. And then this side here is side C. Yeah, this is D. And you'll always get one obtuse, one acute, because they're going to be on opposite quadrants, those two angles.
What about the quadrants below?
Well, we will never have those angles bigger than 180 in a triangle.
Because trapeze artists? Because you can't go.
Well, because the sum of the angles is 180. So how could you have an angle bigger than 180 in the triangle?
The ground.
No, you would have a different triangle on the other side, and you would label those angles positively. Okay, so here, and this is angle C up here, and this is angle E down here. Okay, so those are our two triangles. Let's work them separately.
No, but it was that looked like that. Well, it's almost.
All right, let's go here. Yeah.
In the second triangle, C shorter.
C is shorter than the second triangle. Yes. It looks visually shorter, and we're going to find that it is shorter.
Is it okay?
But angle E is bigger in the second triangle and smaller in the other triangle.
I picture like almost. It was like a graphic, and right now the 5 level one is like it's a different slope. It's like a negative slope.
Kind of. Yeah, it's the two different slopes
So it's
of
gotta
that.
move to the
Yeah.
other side of the line.
Yeah. Yeah. Okay, so let's go. Let's find side C, and then we'll use that to find angle C. Okay, so let's go first. We'll say 5 over sine 32. Oh, sorry. No, I need to use this side length here. No, we're going to find angle E first, because angle E is available to find by sine law. So we're going to go sine 32 degrees divided by 5 is equal to sine E divided by 8. Multiply that through 8 sine 32 degrees over 5 is equal to sine E. So let's go. 8 times 32, but I take the sine of it. Divide by 5 equals 0.84. Notice that that's less than 1. And when that's less than 1 and this side here is less than that side, you have two possible triangles. This is a two possible triangle situation. Okay, so then sine E, so we take the inverse sine of that, and that's angle E here. 58 degrees. 58 degrees. Cool. So there, angle E equals 58 degrees. And that gives us angle C. What's angle C in this case? Good. It's a right angle triangle. Wow. You can have the right angle up there, just not over here. If it's over there, then it's only one triangle possible.
Why?
Why? Because that's where the trapeze artist just skims the ground, just barely touches. Gets on the horse and rides away, no problem. In this triangle, this trapeze artist ain't riding off into the sunset. He slams into that horse pretty hard. So, okay, there is another angle for angle E. The other angle is going to be 180 degrees minus 58. Is also equal to angle E, but up there in that triangle. So I'm going to switch to another color. And that's 180 minus 58 is 122. This is 122 degrees. This is 32 degrees. And we're going to come back to that triangle in a second. But that angle up there, C, is going to be 154 minus 180 minus 154. That's 26 degrees up here. So C was either 90 degrees or 26 degrees. So we've got those two different measures. Notice that angle C and angle C do not have this type of relationship with the 180 minus, or the 180, or just the angle there. These angles E. It's angle E that we have, we're solving for in sine law. It's the one that's ambiguous. So it's the one that could be itself or 180 minus itself. Angle C, you just have to work it out based on those two different values for E. Okay, now let's go ahead and we'll solve for side C in both triangles. So this one is a right angle triangle, so we can just use sine 32 is 5 over C. So let's go for that. I'll do it in red for fun. Sine 32 is equal to 5 opposite over hypotenuse, 5 over C. Multiply both sides by C and divide both sides by sine 32. Gives us C equals 5 over sine 32. Okay, evaluate that will give us C. 5 divided by 32, but we take the sine of that, equals 9.4. So in this case, C equals 9.4, and we can put it right on our diagram.
So is this kind of like astrology way? Like,
No, this is new, that we can have triangles that have two possibilities depending on how you draw the diagram.
How do you?
it could have been almost technically, you could have known that last time.
I think we've led up to this point pretty elegantly, don't you believe?
Yeah,
I think so. It just shows you, and the reason we have ambiguous case of the sine law and we don't have ambiguous case of the cosine law is because sine is positive for values of theta between 0 and 180. Those are all triangle angles. Cosine is positive, meaning could give you the same output, for when cosine is between 270 and 90. So we only ever see the positive ones in between 0 and 90 in triangles. You'll never have negative angles in triangles or angles between 270 and 360.
Tan has two different sectors.
And we don't even have a tan law. So yeah, and tan is divided in checkerboard pattern. Yeah, so that's different. All right. Can I what? Sorry? Oh, scroll down? Yeah, sure. There. And then over here, let's evaluate the length of side C. Okay, so we would have, I'll do this one in big dark blue. So then C over sine 26 degrees. So that's this one over that one is equal to 8 over sine 122. Okay, multiply both sides by sine 26 to cancel, and you will have C equals 8 sine 26 over sine 122, and we solve for C. C equals boop, boop, 8 times 26, but I take the sine of it, divided by 122, but I take the sine of it, equals 4.1. We've got it, so we can put it on our diagram, equals 4.1, and there we go. That's both of the triangles solved. Notice C is more than double the length there that it is over there. Very different triangles.
It's ironic how the acute angle has the larger.
Don't you think? It's a little bit ironic. Yeah, I really do think.
I really do think too.
Yeah. So this is just walking through the example. We see all the values, and yeah. And so if you wanted to solve it, you could say, well, here, these are all the different things.
Mr. Jennings, how do you know which angle reflects on the other side of the coordinate plane?
Oh, like which one is going to do that? It's the one that you just solve for with sine law. If it's ambiguous, it's the one that's going to have that ambiguity to it.
The one that you signed, it's one that you find for first.
Yeah. The other one that's unknown is similarly going to be so ambiguous. Like it's going to have two values, but you work those two values out by first finding that angle that's like the flipped trapeze artist, and then just evaluate using 180 minus the other two angles.
What do you visualize when you're doing this?
Oh, I visualized the trapeze artist. Yeah. So I have for you here more handouts on this, but you will also find if you work on the textbook problems that I'm sure everyone was struggling with over the weekend. Okay, let's take a look at these textbook problems. He says, smiling.
I didn't get around to them, unfortunately.
Yeah.
Textbook questions on Thursday night, though.
Okay, here. Schedule. We're going to go big, and then we're going to end the video just to show you the schedule. I have more handouts for you right now, but also you can look at these questions on two-dimensional trig. These ones. Boop. Where? Highlight. Yeah, you can try these questions, and they include some ambiguous case of the sine law. There's also new handouts on sine law. One last announcement before I finish the lesson. I have your attention. After school online tutoring starts tonight, 7:30 to 8:30. It's not required. It's not for your mark, but if you show up and you show me you have skills that you couldn't show me on the test, I can absolutely record that. So it is for marks in that way. Tonight's topic will be inverse operations. If you want to review any inverse operations using subtraction to clear addition, using multiplication to clear division, using rational exponents to clear exponents, using inverse trigonometry to clear trigonometry, all of those are examples of doing the same thing to both sides of equations to solve them. Also, exponential expressions might make an appearance from the last test. So lots of different foundational skills there to look at with that. The link will be on the front page of the D2L, 7:30 tonight, for anyone that wants to come. Yeah, this will, no, that would, yeah, that would cover units 1 through 4 actually, but different skills inside 1 through 4. I'm going to take different slices and review different things in that way and focus on foundational skills. So thank you again for showing up for your learning. Any questions if your team learn at home, hit me up by email. Otherwise, bye.